Hello, this is John Burke. I'm a visiting lecturer at Reseba University, and today this is the first video lecture on digital currency. I spoke about digital currencies when I was in Reseba a couple of weeks ago, and today I want to talk about what I'm going to call the ontology of Bitcoin. So what is ontology? So ontology is the philosophical study of being, which seems rather odd when we're talking about digital currency or Bitcoin. But my inquiry is what or how is the being of Bitcoin? And what do I mean by that? I'm trying to identify exactly what it is. So we're going to start with three main concepts. Computers, cryptography, and ledgers. So Bitcoin, as we all know, it exists on computers. So what can that possibly mean? Computers ultimately retain or contain, track information by simply a language that is comprised of zeros and ones. Of course, it's the very unique strings of zeros and ones, but that's the language, the fundamental language, the machine language of computers. So a Bitcoin has to be that. It has to be a string of zeros and ones. And it's retained on computers, but where? So then we have to get into this concept of the ledger, which we all know is what is referred to as the blockchain itself. But the ledger is decentralized. So what does that mean? That means that because of computers and because of their ability to replicate things perfectly, that we have the Bitcoin ledger, let's call it, copied thousands and thousands of times across computers all over the world that have perfect copies of, let's call it, the approved ledger. Because if someone comes along with a slightly different ledger that doesn't match the other ledgers, well, it's going to give us an indication that this is fraudulent, that something is wrong with this ledger. So, following my analogy that starts from the basics of computer language that is machine coded into zeros and ones, bits and bytes, but of course they're unique strings or addresses that we call by using certain methods. Then, of course, the next thing we have is cryptography. So what is cryptography? Well, cryptography is very complicated. But at the beginning, let's just call it the science of encryption, decryption, ways of transforming messages into digests or fixed strings of particular data. It's complicated, but let's just start there. So what do I want to say so far? So we know that Satoshi Nakamoto published his white paper in 2008, at the end of 2008, actually, October 31. And that was the same year that we had the 2008 financial crisis. Now, is this coincidence or not? Well, I don't know. I tend to think it's really not coincidence. Because if we look at the prehistory of Bitcoin, it goes all the way back to the 1980s with a mailing list called the Cypherpunks. And if we look at the references in the 2008 white paper, we'll see names like Adam Back, Haber, Merkel. These were people that were, and not the only ones, of course, that were involved in the development of finding ways to communicate across insecure channels in safe ways. In other words, to share secrets between two or more persons, even though we're going to transmit this data across insecure channels where it can be intercepted by the so-called bad actor. And so many different types of cryptographic primitives were developed during this period, essentially based upon mathematics. The other thing that I want to mention as a slight piece of history, probably none of you remember it, was there was a system called Napster. It was a way that people could share their music libraries. Of course, it was illegal because it violated all sorts of copyright law. But in any event, how did it work? So the creative guy who started Napster, what he did was he had a central server, and unfortunately this is the weak point that Nakamoto solved, that contained not songs. There were no songs on this central server. What he had on the central server was a list of songs or music that users had on their computers. So if you were to use this system, which I did because I'm old enough to have used this system and it worked great, I loved Napster, you would, let's say, log into Napster, and you would say, okay, I want to look for a song by the Beatles or by Bach or by whatever your favorite group is, and you type the title of the song, and you would be linked to another user who was online at that time, and then your computer, you were the peer, and the person whose library contained the song that you wanted, that person was also the peer. Then you simply made a peer-to-peer connection and shared the music. So that person would simply transmit you would download the music from that person's computer, and vice versa. If I also had a library of songs, and if I were online and people wanted my songs, I could share my songs with them as well. But so Napster was a great system, and it operated for, I'm going to say, a couple of years. But what was the weak point? The weak point was this central server, that the only thing, let's call it, the cops had to do was just shut down or physically seize that central computer, and Napster was gone. Now, I don't know if Napster was actually closed down in that manner. Certainly there were lawsuits against the operator of Napster for copyright infringement and intellectual property infringement rights. So it may have been a little bit more civilized. But in any event, if we want to make it dramatic, we could say that, the FBI raided the person's house where the Napster server was held and physically seized it, took it away, and the whole system went down. This is mission impossible with Bitcoin. Why? Because Bitcoin, it solved this problem of the central server, knowing that any system that uses a central server has a major weak point, and that is the single server. So what Satoshi Nakamoto did is he took what in banking is called the ledger of accounts, let's say. But instead, he made his ledger a perfect copy so that it could be multiplied tens, 100s, thousands of times over. And that same perfect copy, which is usually considered a problem in the digital world because we can't tell the real one from the fake one, but we'll see how he figured that out, maybe not in this lecture, but in later ones. And he allowed users to retain individual copies of the entire Bitcoin ledger. So this is called a decentralized information system, a decentralized ledger. Now your Bitcoin it exists on ledgers, but it exists on the ledgers in terms of how a computer works. So your value, your Bitcoin value, exists on ledgers, and it must ultimately be machine coded. But we also know that you have to have access to it. How do you get access to your Bitcoin? Well, here comes an element or a cryptographic primitive called a public-private key infrastructure. So when you have an address or a unique string of zeros and ones that are representative of a value, that's the really cool thing as well. It's representative of a value because how can zeros and ones be of any value? Well, it is considered value because the value of Bitcoin is based upon supply and demand, and based upon the fundamental principles of microeconomics. And the other thing we know is by terms of the Bitcoin protocol that Bitcoins already exist. There are 21 million Bitcoins, but they're not all yet mined, let's call it, or brought into existence, because each Bitcoin that is released from, let's say, the vault or the mine has to be released by means of what we will call proof of work, but I'm not going to get into that now. So this is what miners do. So now we have to go back to, let's talk about the first Bitcoin. So here I am, I'm Satoshi Nakamoto. I developed this great system. By means of writing my protocol, I developed my decentralized ledgers. I'm also going to have a very specific format of the database, which I'm going to organize my transactions in Bitcoin in blocks, and I'm going to tie those blocks together so that it is almost impossible to reverse engineer any previous block that has been validated by the consensus system of Bitcoin. So there I am. I'm going to make believe I'm staring at my computer screen, and there are no Bitcoins that I can see, but I know there are 21 million of them. So somehow the first Bitcoin has to be brought into existence. So my understanding, and I cannot find any contrary view with all of the materials I've read and all of the resources that I've looked at, is that Satoshi Nakamoto had to use his own process of mining to bring that coin into existence. And once the coin is brought into existence, it's brought to existence on the decentralized ledger, and it is represented by this unique string of zeros and ones. But how does Satoshi Nakamoto know that he owns this thing? Well, at that time, he did not develop asymmetric cryptography or public-private key infrastructure. These were developments that were made by many other people and many other scientists, but he deployed them in his new system that he would call Bitcoin. And so what he did was what we could say linked or tied that Bitcoin value to what's called his private key. Now, what does that mean? And I have to do a lecture on public-private key infrastructure so that you understand it. But, okay, we have now the first Bitcoin brought into existence, or Bitcoins, because the first proof of work brought into existence more than one coin, but it doesn't matter. For purposes of our illustration, we could just say one coin. So there it is. What do I do with it? So I can then claim ownership of that Bitcoin with a private key. In other words, the only person who has the ability to use that value, to, let's say, unlock the value that exists on the decentralized blockchain, would in this case be Satoshi Nakamoto, who has his private key, and that private key is joined to his units of value on the ledger, and he, by virtue of his private key, is the only one who can unlock that value and then have the capacity to transfer ownership of that particular Bitcoin from him to someone else. Now, the interesting thing about this is that the value in and of itself, let's just call it an address, it's public. Anyone can see that that Bitcoin exists, that that particular value exists, but only the person who has the private key can actually use it. And if we look at Satoshi Nakamoto's sentences, his own language, let's look at one of the sentences. I think it's the first sentence in section 2 of the white paper, which is entitled Transactions. So he says, we define an electronic coin as a chain of digital signatures. So this is very interesting because now he's introduced a couple of new terms that I haven't defined yet. Of course, I've identified what a coin is to the best of my knowledge and based upon the resources that I think are the most credible. But then he says it's a chain of digital signatures. So we're going to know what chain means because he's talking about hashes and links, and he's talking about cryptographic primitives. But then he introduces the term a digital signature, which we haven't discussed yet. And I'm going to discuss a digital signature in a separate lecture. But let's move on to the very, very next sentence, because I think this is revealing and very telling. He says, each owner transfers the coin to the next person by digitally signing, there it is, digital signature again. But Then he says signing a hash of the previous transaction and the public key of the next owner, and adding these to the end of the coin. All right, now this is starting to get really complicated, right? So, but let's, for purposes of this lecture, let's try to keep it really simple. So he says each owner, okay, so I'm going to make believe the only owner here is Satoshi Nakamoto, because he's the first one who brought the coin into existence through the process called mining, which we'll get into, proof of work. So he's an owner. So in his own words, in the white paper, he says that if I'm the owner, how am I going to transfer this coin? So he says I can transfer it to another person, let's say his friend Hal Finney or whoever, by a digital signature. But what is he signing? He says he's signing a hash of the previous transaction. Well, what's the previous transaction? Well, the previous transaction can only be the fact that he brought this thing into existence. And then he says, and the public key of the next owner. So here he's presuming, and let's assume for the purpose, that we just have two people, Satoshi Nakamoto and Hal Finney. And Hal Finney, of course, is like another one of these geniuses who is involved in the mailing list and extremely well known. Well, both Satoshi Nakamoto and Hal Finney would have their what are called commutative pairs of private and public keys. And what do I mean by commutative pairs of public and private keys? It means that these keys are mathematically related one to the other, so that Satoshi Nakamoto's, when he creates his private key, and we'll see this in another lecture, he can create his public key from the private key. Oh, and by the way, it can go vice versa. He can create the public key and get the private key. But they're unique. They're uniquely paired. But in my example, Hal Finney has done the same thing. So he's created his private key and his public key. So let's take this sentence again. So each owner transfers the coin to the next by digitally signing a hash, which I'll tell you what a hash is. But basically a hash is an algorithm that takes an input, and the input could be anything. And when you run it through the algorithm, like RSA algorithm, it produces a deterministic fixed length character string such that it has some very definite properties, but such that if you make any alteration to the input, you immediately will see a change in the corresponding digest, the deterministic fixed length string, and it's the slightest change will make a huge difference. So that's a hash. And of course, what is he hashing here? Well, he's probably hashing his transaction, his messages. He's hashing also his value, the coin. So what is he doing? So he's, we'll get into this later, but he's going to use his, he's going to set up a message. He's going to use his private key. He's going to use a random number. And of course, he's got to use then a new algorithm called the digital signature algorithm. And this will produce a particular output, a result, which will uniquely identify him as that he signed it. So how is the next person is Hal Finney going to figure out that Satoshi Nakamoto actually signed this thing? Well, he's going to use Satoshi Nakamoto's public key. And this public key will assure, because the public key is just that, they're all public. And the public key will enable Hal Finney, the recipient, to apply it to this message that he receives. And he's going to be able to verify that, yes, Satoshi Nakamoto, in fact, was the sender, in fact, signed this message. And so we know that the originator was Satoshi Nakamoto, that the message has not been altered in transit, and that the transaction is valid. I'm going to stop there now because the only thing I wanted to really get into was getting my head around what is this Bitcoin in terms of its being, in terms of what is it as an object. And as an object, it simply can only be, at its very base, machine-based code. Zeros and ones, of course, that are unique, that are mapped to an address. That address is on all of the ledgers. So the ledgers are everywhere because they have to be, because that's the beauty of the system, is that assuming that each ledger is, that each node is maintaining a ledger identical to all the others, and that as a group, the majority says that yes, this ledger is valid, it contains verified transactions, we can depend upon it, we can rely upon it, we don't need any third party to tell us it's correct. Why? Because we're using the mathematics of the underlying protocol to know that it's accurate. So that is the Bitcoin. Your keys, your private and public keys, which you may store in a wallet, which can be online or in a physical device that's offline, what these enable you to do is to unlock the value. I mean, not everyone can be able to unlock these values, even though they are public, you can see them, but in order to spend them, you have to be the actual owner. So I'm going to stop there for now. I have a lot more to go into to clarify what I have just said, and to go a bit deeper into detail and to categorize for you hashing, digital signatures, and public and private keys and how they function, so that you basically understand the fundamental architecture of Bitcoin. And the other thing we'll have to look at also is the contents of the blocks, the method in which they're verified by this proof of, they're verified by actually keys, but they are validated by proof of work. And once they are validated by proof of work, then we know that, again, here comes hashes, that one block is chained, or linked to the other block by a hash. So I'm going to stop there now. I hope my plan is to release these things periodically, so that I can put all of the lectures up on YouTube and we can get through this course. If you have any questions, I gave you my email, and I have some fairly good links, and in the in the text below the video, I will try to provide links to sources that you can look at yourself. So goodbye for now, and thank you.